When we talk about the water crisis, we often focus on the fact that less than 3% of the world's water is freshwater, and most of that is locked in glaciers and ice caps. But the real problem isn't just a lack of water, it's the quality of the water we have. Contamination from industrial waste, agricultural runoff, and outdated sanitation systems makes billions of gallons of water unusable. This is where innovation comes in. We need to find ways to take the water we have, whether it's brackish, contaminated, or even salt water, and make it safe to drink. This leads us to the cutting edge of water purification. One of the most promising technologies is nanofiltration. Think of it as a superfine sieve for water. Traditional filters use a physical barrier to block large particles, but nanofiltration membranes have pores that are only a few nanometers wide. To put that in perspective, a nanometer is a billionth of a meter. These tiny pores are small enough to remove not only bacteria and viruses, but also dissolved salts and a wide range of organic contaminants, including pesticides and pharmaceuticals. How it works. Water is pushed through a semi-permeable membrane under pressure. The membrane's pores are so small that they allow water molecules to pass through while blocking larger contaminant molecules. The advantages: nanofiltration is more energy efficient than older methods like reverse osmosis, making it cheaper and more accessible. This makes it a game changer for purifying everything from industrial wastewater to drinking water in developing regions. Sponge cities, harnessing the power of nature. While nanofiltration tackles the problem of water quality, a different kind of innovation is addressing the issue of water management on a grander scale. This is the concept of sponge cities. The traditional urban model is designed to get rid of water as quickly as possible. We build concrete streets and underground pipes to funnel rainwater away, but this creates a dual problem: floods during heavy rain and droughts when it's dry. A sponge city does the opposite. It's an urban design philosophy that uses natural elements to absorb, store, and purify rainwater. Instead of paving everything, these cities use permeable pavements. These special surfaces allow rainwater to seep through into the soil below, recharging groundwater reserves. Green roofs and walls. These not only reduce the heat island effect, but also absorb significant amounts of rainwater. Rain gardens and wetlands. These engineered green spaces are designed to temporarily hold and filter rainwater, naturally purifying it before it enters the water table or local reservoirs. The goal is to turn the city itself into a living organism that can effectively manage its own water cycle. By absorbing water during storms, a sponge city prevents floods. By storing that water in the ground, it builds up a reserve to be used during droughts. The global water crisis is a complex, multifaceted problem, but the solutions are just as innovative and interconnected. Nanofiltration gives us the technological ability to purify water with unprecedented efficiency. Sponge cities provide us with the architectural and ecological blueprint to manage water on an urban scale. These aren't isolated solutions. They represent a holistic approach. We are learning to work with water, not against it. By combining cutting-edge technology with thoughtful urban design, we can build a more resilient and sustainable future for our planet. The conversation is no longer about despair, but about ingenuity, adaptation, and hope. Thank you.